Good morning. Myself TELI, faculty in Mechanical Engineering Department, Saraswati College of Engineering, Kharghar, Navi Mumbai. Today I am delivering a lecture on fluid mechanics. Especially in this lecture I am covering the basics of fluid mechanics. The first definition of fluid. Fluid means what? Easily flow. Fluid may be liquid or gas. The combined word is called fluid, and especially the fluid mechanics. The definition of fluid mechanics. The study of behavior of the properties under statics as well as under motion is called fluid mechanics. What are the properties we are studying? The basic properties or main properties are the pressure, density and mass density, weight density, specific gravity, so viscosity. These are all properties of the fluid, and fluid mechanics will classify the fluid mechanics into three parts, especially that is called statics, fluid statics, then kinematics and fluid dynamics. We will classify like this: fluid statics and fluid kinematics and fluid dynamics. Here in the statics, the study of behavior of the fluid under rest. In kinematics, the study of fluid under motion without considering pressure force. And fluid dynamics is nothing but the study of fluid properties under motion as well as by considering the fluid pressure force. The first is, what are the basic properties of fluid? The basic properties of the fluid, there are four properties. The first is density or mass density. That is rho. Second one is weight density or specific weight density or specific weight. Next is specific volume, specific volume. The fourth one is called specific gravity or a relative density There are four very basic. So some are many properties are there. These are called viscosity, surface tension, capillarity. Okay, these are the but basic properties. The first one is the density. The density is nothing but mass of fluid divided by volume of fluid. So the unit of mass is kg, the unit of volume is meter cube. The rho equal to m by v means what? How much the mass is occupied by the fluid for a unit volume. Otherwise we can define like this: the mass per unit volume. The mass per unit volume is called density. This is very important because density shows the compactness. For example, the ship thousands of kg, lakhs of kg, but still it is not sinking. but a gram of stone is sinking in the fluid. So, due to what? The very important is density, because the density of the ship is lesser than the density of water, but the stone density is more than the density of water. So, density is very important property in the fluid. Second one is called weight density. So, weight density is nothing but weight of fluid divided by volume of fluid. So, weight of fluid is Newton, volume of fluid is Newton meter cube. So, here weight is nothing but m into z divided by v. Already I know m by v is rho into z. This derived unit, the symbol is omega. Here also, how to define the weight per unit volume of fluid. Okay, this is a derived unit, but this weight density will be very much helpful to find the weight. Weight of fluid is equal to what? Omega into volume. So, in a liquid, we will find the weight of the liquid by using weight density. Once we know the weight density, then easily we can find the weight of the fluid. Next one is specific volume. The specific volume is equal to volume of fluid divided by mass of fluid. So, here the volume is V divided by m, that is m by V. We know that m by V is rho. This is meter cube per kg, meter cube per kg. So, exactly it is the reverse of density, especially this specific volume is in a very much important property in the what airfoil bodies, especially in a helicopter and aeroplane. The part should be what? High specific volume, means volume is more and mass is less. And the fourth property, the next one is the fourth property is what? Specific gravity. In specific gravity is nothing but our relative density or relative density. So, the definition is like this: specific gravity is equal to density of fluid divided by density of standard fluid. So, it shows the what? The is it a lighter fluid or is it a heavier fluid? We can identify it by using specific gravity, especially the specific gravity of liquid. Specific gravity of liquid is equal to what? Density of liquid divided by density of water, because here I took standard, the standard is a water. Like this, specific gravity of gas equal to density of gas divided by density of air. Like this, the specific gravity of solid is equal to density of solid divided by density of water only. So, like this we will find a specific gravity, means especially in the liquid, the specific gravity of for example, specific gravity of water is 1, because density of water is 1000 kg per meter cube. Like this, specific gravity of mercury 13.6, density of mercury is 13,600 kg per meter cube. Okay. So, we have seen the what are the basic properties quickly. Now we will move to types of fluids. Basically there are two types of fluids. Basically only there are two types of fluids. One is what Newtonian fluid, other one is called non-Newtonian fluid, but broadly we are classifying like ideal fluid, then real fluid, then Newtonian fluid, then non-Newtonian fluid, then ideal plastic fluid. So, if you see the types of fluid flow, types of fluid flow, the first one ideal fluid flow, second one is called real fluid flow, third one is called Newtonian fluid flow, the fourth one is called non-Newtonian fluid flow, fifth one is called ideal plastic fluid flow. If I draw the graph here, if I draw the graph of all the type of fluid, okay, especially I will call shear stress Newton per meter square. Okay, I will talk about the shear stress later. What is du by dy? The du by dy is the rate of strain or velocity gradient. So, no velocity gradient because viscosity is 0, ideal, then this is called Newtonian fluid, this is called non-Newtonian, both are real, this is called ideal plastic. So, like this we will classify. Okay. So, unit is per second. Here in the ideal fluid the viscosity is 0 as well as it is incompressible, and real fluid all are real fluid because all fluids virtue of viscosity, and Newtonian which are the fluids obey the Newton viscosity law. I will explain later. Tau equal to mu du by dy, and non-Newtonian the fluid which are not obeying the Newtonian law. Then ideal plastic means what? Before there is a velocity gradient, it has the stress is developed, and after that the stress goes on increasing. Now, one more important concept is called viscosity. One more important concept is called viscosity. In viscosity, suppose how to define the viscosity, what is meant by viscosity? So, it is a very important property in a fluid, viscosity. So, there are two fluids in my hand. If I ask to somebody which fluid has more viscosity, the fluid which is easily flowing less viscosity, the fluid it is not easily flowing more viscosity. Okay. So, this is the type of viscosity. Here the Newton, actually the Newton was found out the resistance between the fluid layers, resistance between the fluid layers is called viscosity. For example, what Newton's exactly done, he took some layer of fluid, say thickness is T, and he was observed that the velocity along the y axis goes on changing. At the bottom 0, then some velocity we can show by vector quantity. Then if you join like this, so Newton has got some parabolic, especially the parabolic profile he has got. This is a velocity profile. the figure is called velocity profile. Parabolic profile, that is y is equal to a, the velocity u equal to a y square plus b y plus c. Okay, there are three constants we can find by using boundary conditions, three boundary conditions. Here t equal to 0 and here the thickness or y equal to t, here y equal to 0. When y equal to 0, the velocity is 0. When y equal to t, the velocity will be max, u max, maximum velocity here. And one more, if you see that at the end, okay, nearly the same velocity, if I draw the slope with respect to y axis, because this is a y axis, with respect to y axis, the slope when y equal to t, the slope du by dy equal to 0, du by dy equal to 0. By using three boundary conditions, we can find the ABC value, then we will get a profile. Sometimes you will get a linear profile also. When the velocity is low, you will get a linear profile, velocity linear profile. And here if I take a small element, then there is a shear stress will develop. So why the shear stress will develop? Because Newton found out the shear stress is directly proportional to the velocity gradient as well as viscosity. So that tau equal to mu du by dy, this is called Newton's viscosity law. The unit of mu is what? Newton second per meter square. Now we can define the viscosity. The shear stress is required to produce a unit rate of shear strain. The shear stress is required to produce a what? Unit velocity gradient in the fluid. So SI unit is Newton second per meter viscosity, but still we are using a MKS unit, that is called poise. 1 poise is equal to 1 by 10 Newton second per meter square. This is called, mu is called coefficient of viscosity or dynamic coefficient of viscosity. Okay, tau is called shear stress and du by dy is called rate of shear strain. And what he has observed here, the slope is with respect to y axis, the slope is goes on increasing. Here there is a maximum, du by dy is max. If I draw the shear stress diagram, shear stress is exactly reverse. The shear stress is goes on increasing. Shear stress is goes on increasing. Shear stress is goes on increasing. So one more word in the, or one more derived unit is called kinematic viscosity. So kinematic viscosity is equal to dynamic viscosity divided by density. So kinematic viscosity is equal to mu by rho. Okay, if you see the unit meter square per second. So but the MKS unit, the one stroke is equal to 10 to the power of minus 4 meter square per second. Okay. So even if you see the dynamic viscosity of water is very less, that is 1 centipoise, 1 Cp, 1 centipoise. The density of water is especially the density of water is high 1000, but the viscosity is low. So this is all about the viscosity. Okay. Now here we would like to solve one problem based on Newton's viscosity law, that is tau is equal to mu du by dy. This is called Newton's viscosity law. So, shear force, then shear force is equal to what? Tau into A, or loss of then torque is equal to what? Force into d by 2, and power, there is a power loss is equal to what? 2 pi n t divided by 60. Definitely there is a loss of power due to the fluid in the form of heat, and sometimes if it is a linear velocity, then power loss is equal to what? Force into shear force into velocity. This is a linear displacement. This is in the angular displacement if the shaft is rotating. For example, here suppose there is a plate is moving 3 meter per second, and mu is what? 0.1 poise. Then to find the how much the shear force is required, or to find the power loss, first of all you draw a velocity profile. The velocity profile is like this, okay, and here this is a fix, here u equal to 0, here u equal to how much? 3. So, that du equal to 3 minus 0, that is 3 meter per second, and the thickness say 2 mm, so that the thickness dy is equal to 2 into 10 to the power of minus 3 meter, and mu you know 0.1 into 10 to the power of minus 1, 0.01 Newton second per meter square. So, tau equal to mu du by dy, 0.01 into du 3, dy is 2 into 10 to the power of minus 4, you will get a tau value, that is 1.5 into plus 3, 10, 150. To find a force, if you see the free body diagram, this is opposing force, shear force. Okay. So, force required. So, force required is equal to what? Suppose the area of cross section is 3 meter square. So, force required is equal to shear force, that is tau into area. So, tau is 1.150 into area is 3, that is 450 Newton. How much is the power loss? Power loss is equal to 450 into velocity is 3. So, something, so you will get a watt. So, like this we will find the how much the shear force is required, shear torque is required, and power loss by using what? Newton's viscosity law. Okay. Sometimes both the plates are moving in the same direction, sometimes above plate is in right direction or right hand side, below will be left hand side. That moment we have to adding both the velocity du in the same direction, subtracting. Okay. So, this is what about the this is the very fundamental and basics of fluid mechanics. Okay, thank you.